Hello, everyone, and welcome to TDWI's webinar program. Thank you for joining us today. I'm Linda Briggs. I'm an editor here at TDWI, and I'll be your moderator. Our program today is Putting the Intelligence in Your Company's Approach to Artificial Intelligence. It starts with the data. Our sponsor is Pitney Bowes. And for our presentations today, we'll first hear from Fern Helper with TDWI. After Fern speaks, we have presentations from Larry Hall and Dr. Chandra Baji, both with Pegasus Knowledge Solutions, Inc., or PKSI. Before I turn the time over to Fern to get us started, let me go over a few basics. First of all, our webinar will be about an hour long. At the end of the presentations, the speakers are going to host a question and answer period. So if at any time during any of the presentations you have a question, just go ahead and type it in there on your console. There's an Ask a Question area there, and send it over. We'll get to as many of those as we can toward the end of the webinar. If you run into any technical issues, there is a help area there on your slide window. You can click on that for technical assistance. If you're a Twitter user and you'd like to discuss this webinar on Twitter with fellow attendees, please include the hashtag TDWI in your tweets. Finally, for a copy of today's presentation, there is a line on your console for that. You can download a PDF immediately. In addition, as always, we're recording today's event, and we'll be emailing each of you a link to the archive so you can view the presentation again later yourselves, or please feel free to pass that link along to colleagues who may not have been able to make it today. Okay, once again, our program today is Putting the Intelligence in Your Company's Approach to Artificial Intelligence. It starts with the data. Our first speaker today is Fern Helper, who is a TDWI Vice President and Senior Director of TDWI Research for Advanced Analytics. Well known in the analytics community, Fern has published hundreds of articles, research reports, speeches, and webinars on data mining and information technology over the past 20 years. Fern is also co-author of several dummies books on cloud computing, the hybrid cloud, and big data. She focuses on advanced analytics, including predictive analytics, social media analysis, text analytics, cloud computing, and big data analytics approaches. She's been a partner at industry analyst firm Hurwitz & Associates and a lead analyst at Bell Labs. Her PhD is from Texas A&M University. So Fern, good to have you here as always. Let me turn the stage over to you.
Great. Thanks, Linda. Hi, everyone, and thanks for joining us on this webinar today about AI and data. We know you're busy, and we appreciate you taking the time out to be with us. So let me start off by defining what we mean by AI. And of course, AI can mean different things to different people. We'll be using a somewhat narrow definition here, and you can see it on your screen. AI is the theory and practice of building computer systems able to perform tasks that normally require human intelligence. So these advanced algorithms are being used to gain deep analytics insights. They're being embedded into software across the analytics lifecycle. They're being utilized in business and consumer apps. AI, I have some of the technologies that AI includes. It includes things like machine learning and natural language processing, as well as other technologies such as speech recognition, computer vision, and more. What we're seeing at TDWI is that a lot of the action around AI that's in the market today has to do with machine learning. So a lot of organizations looking to machine learning. So here's what we're going to talk about today. I'll start off by discussing trends, use cases, and challenges for AI. I'll also talk about 4 pillars for successful AI implementations and discuss the importance of data to AI. And then I'm going to turn it over to our other speakers from Pitney Bowes and Pega Systems to discuss more about real-world challenges and best practices for solidifying AI as a strategic initiative. So they'll talk about what they're really seeing out there and how to move forward. So organizations, what we see is that organizations are making use of AI technologies in numerous ways. Some of these sound familiar, such as using AI to build churn models or to predict fraud. These are the traditional use cases that also include things like understanding customer behavior or predicting an event, those sorts of things. Other organizations have been using more what sound like forward-looking AI solutions. They've been trying to implement them. And these include things like predictive maintenance, which uses IoT data, image recognition, So using deep learning to actually classify images, using text analytics, with NLP to actually be able to extract information out of text documents. So, for example, organizations are using text analytics to determine sentiment or what the customer is saying about a product, and then that information is extracted from the text and is oftentimes used as input to a machine learning model that can increase the lift of a machine learning model. Then there's the more revolutionary kinds of AI. For instance, AI is being explored for use in prosthetic devices that actually can distinguish images and detect pressure. Deep learning is being tested on images to identify cancers or whether a tumor is responding to treatment. There's been a lot of agricultural advances with AI that include things like ground robots and in-field monitoring using drones that can determine whether a crop needs watering or is being infiltrated by weeds or some other invasive species. The point is that AI is being used across the organization, and what we see, it's being used across industries. What we're seeing at TDWI is that those organizations that are already using AI technologies are gaining value from it, whether it's from these familiar use cases or from something that's more futuristic. Why are they thinking about AI and machine learning? So in recent surveys, we've been asking questions about the value and necessity of these technologies. And I have two charts here from two different surveys. In the upper left, there's a chart about advanced technologies such as AI being critical for competitive advantage. So here we asked if respondents agreed, disagreed, or were neutral about the statement that advanced technologies such as AI are critical for competitive advantage. And you could see, I circled it, it's that big blue part of the pie chart there, that 90% of respondents agreed with that statement. As organizations look to digitally transform, these technologies are becoming more important. So in fact, in my most recent survey for my best practice report on AI that hasn't been published yet, I'm seeing that more than a third of the respondents that are using some type of AI technology have actually measured a top or bottom line impact from these technologies and the projects that they're deploying. So you can see I circled it there, it was over 30-something% are actually, measuring a revenue impact, either cost reduction or increase in revenue. More than half believe that the projects and programs have been valuable, although they can't actually measure the impact. And you could see here that only a tiny percent, 7%, who are using these technologies have not been able to measure any value from the efforts. So definitely, there's value to be had with these technologies. So this value may also be why demand is increasing for AI technologies. So what we see is that machine learning, predictive analytics machine learning is a strategic imperative. This chart actually comes from a late 2018-2019 survey that we did where we asked respondents how the demand for more advanced analytics such as predictive analytics or machine learning or even text analytics has changed in your organization over the past year. And you could see that 35% said it's increased slightly and 29% said it's increased significantly. So that's 64% say that it's increased. You could see over on the right in the brown and the yellow bars that, only a couple percent are, actually saying that it's decreased to some degree. So the demand is increasing, it's not decreasing. It's doing that across industries and across company sizes. What we see is that industries such as, high-tech, telecommunications, utilities, those sorts of industries, do tend to be more advanced than, say, industries such as education in using these technologies. But we do see that even industries that, were far behind, or not far behind, but, somewhat behind in analytics, such as healthcare, they're really like ratcheting it up. So there are a lot of use cases across industries like education for these technologies. And also what we see is that a lot of a lot of this starts in companies that are large, but nowadays it's happening sort of across company size. So in order to get started with AI and machine learning, it's important to think about it across a number of different dimensions. We can call these dimensions pillars. TDWI, we do a lot of work putting together models for readiness models for certain types for analytics or maturity models, and so we tend to think of groupings of things together. So these are the 4 pillars that I've put together in terms of AI, and they consist of organizational strategies, data management strategies, analytic strategies, and then governance strategies. And they're good to use as you can use this. I would take all day to sort of go through everything here, but you can use it as a good sort of starting point or point of reference to look at, all of the different factors that should be important to you as you're building out your AI program. And one of the most important strategies falls under the organizational strategies, and that's the top one right there that says right business problem. So it involves identifying the right business problem. I mean, this is key for AI ML deployments. If you don't have a problem that's worth solving and you can't articulate it and map it to some impact driver, then you're going to most likely not succeed with your initiative. It's not like a build it and they will come. I mean, you need to build the right thing. So that's, number one, that always comes up as one of the top best practices for any type of analytics is identifying the right business problem. And then additionally, we see that skills are important for AI and machine learning. Organizations need to develop these skills or partner with a group that can help them to get started. So we typically see that skills are a major challenge that organizations face as they're getting more advanced in their analytics. And ultimately with AI and machine learning, organizations are going to need to consider new roles like DevOps or data ops in terms of putting models into production. Data, if we move to the data management pillar, that's obviously key to any effort, and it's what we're going to focus on in this webinar. And what we see at TDWI is that organizations are dealing with old and new issues when it comes to data and AI. So many are starting with utilizing traditional structured data to build out their models. And this data may come from multiple sources, and data integration becomes very important, as is building the pipeline. We hear a lot these days about building data pipelines and data engineers that can come and help to build out these data pipelines, these complex data pipelines that may be feeding advanced analytics like machine learning. And, these pipelines become even more important as organizations mature and they start to use disparate data sources from different places, even if it's all structured. They often evolve to multi-platform environments, and that's what we see is that organizations, have multiple platforms and they're trying to pull the data from multiple platforms. So issues like data ops in terms of managing data like software actually become really important as organizations start to mature. So what I want to do actually, well, let me go back here a sec, is, because of course then there's analytic strategies and governance strategies, and those are really important too. And these analytic strategies, it's really important to understand what methodologies, work best in which situations. So to understand the methodologies that are available. What we see, I have number 3 on the list here, is operationalization. That always comes up as a top success factor for analytics, and especially models, that you want to put models into operation. And Chandra, who will be speaking in a little bit, he'll talk about, putting models into operation and productionalizing them. Also important, around governance and whatnot is explainability, which is becoming even more important with the advent of tools like augmented intelligence that I'll talk about in a second, as well as, some of the governance rules and regulations that are out there. And what's also important with, analytics is to be able to do model governance and model management and monitoring. So it's not enough simply to develop a model. Once you put that model, you got to get that model into production and, then manage and monitor it. And I'm going to talk about the data issues associated with that in a second. And then finally, there's, the trust and governance strategies, because as you're putting these new tools into production and new programs, you want people to be able to trust what's actually happening there. A lot of that has to do with, data quality, that they trust the data quality of the models that are being built. There are security issues and privacy issues, and with AI, ethics issues are becoming more important, and a lot of compliance. None of this governance stuff goes away with AI. In fact, it becomes even more important. So what I want to do is to drill down into the data management dimension a little bit more to discuss something that's very important when it comes to data and advanced technologies like AI and machine learning. And what I want to talk about are the data considerations, both on the front end of the AI process and then on the back end of the AI process. Most organizations only think about getting to the data to build the model, so building the pipeline, getting that data to the model to actually develop it in the first place. And clearly, obviously, that's very important, and especially as data becomes more complex and bigger. But there are also some important data considerations on the back end after a model is built that I want to talk about. So let's start with the front end of the model building process. So there are several important considerations here. The first is obviously data quality. The old garbage in, garbage out is true of machine learning models also. There isn't some sort of magic that happens to get rid of bad data. In fact, we often see that this is a top technical challenge that's always cited by our respondents to our surveys is data quality, along with data integration. What we see happening is that organizations are looking to automate some of the data quality processing using tools that are infused with machine learning to help do some standardization and duplicate removals and do, automated matching, that sort of thing. These tools that are infused with this machine learning, some organizations and some in the market refer to that as augmented intelligence. So if you hear that term, that's what that's about. What we're seeing is less than about 20% of respondents to our surveys say that they're using these types of tools now for data quality, but another 50% expect to use them in the future. So a lot of room for growth there, and a lot of excitement around these types of tools that can help with data quality on the front end here. Then you get to sort of the meat of the front end, which is around building the data meat anyway, or is around building data pipelines. So as I said, as organizations use disparate data sources, they're going to need to integrate this complex data together. And that might include the data that they have, as well as enriching the data sets using third-party demographic and other data types. We'll hear more about data enrichment in a few minutes. This disparate data can help to provide lift to models, and vendors are offering data pipelining tools to actually help to assemble these pipelines. The tools have things like connectors, and they have drag and drop visual interfaces, and you can save the pipeline and reuse it, and they have a lot of other features, but they can be very helpful in the front end in terms of putting these data pipelines together. And then part of the process, too, around data on the front end is feature engineering, developing features using calculated data. So these features can be simple, like ratios, or they can be more complex, like some sort of metric score. And these features are really an important part of the input to the machine learning model. So, for example, I might have a feature that's a happiness score or a demographic metric, and that may actually be very predictive in terms of a machine learning model. And then even some organizations are building out such complex data pipelines with so much data that they actually have to version. They feel it's really important to version these pipelines, and they think of them as a data product, that then is used for some of these machine learning models. So a lot to think about on the front end in terms of data, and we'll be hearing about the Spectrum product in a few minutes here also. On the back end, there's also things to think about too. So once the model is built and served up, you need to serve it up to some sort of system. In other words, you need to operationalize it. So you're going to put it into production in some sort of system, or some web service or some application, maybe in a database for database scoring. So you built the model in the development phase, and then you're going to operationalize it and put it into production. And so when that model is deployed into production, new data is going to be coming through it, and that data needs to be scored. So you might build a churn model, for instance, and then as new data becomes available, you're going to need to run that data through the model to see what the likelihood of a person churning is, for example. And that means putting together that data pipeline to feed the model again. You know, once the model's in production, the data pipeline doesn't go away. It includes model pipelines, for example, that include, again, recalculating features along with any data cleansing that may have happened along the way. So it's important to understand this. So it's not just about building the model. It's important to think about what happens in production and what data considerations that may involve. You know, that's why many organizations who are putting models into production are developing DevOps or data ops teams to actually deal with the back-end data issues. You know, likewise, the model is most likely going to change. You know, conditions change, environmental conditions change, data changes. And that could be hourly, daily, weekly, monthly, whatever. But you're going to need to actually monitor this and then retrain. You know, chances are you're going to be retraining your model. And finally, it's going to be important to govern the data that goes into the model. That includes things like understanding the metadata associated with the model. I have data and model governance, and I mentioned that before. So who built the model? When did they build it? What are the attributes, that went into building this model? How were the features calculated? So information, about that model, the model lineage, and so on. So operationalizing models is going to be key for going forward in terms of AI and machine learning. And these are some of the data considerations that you need to think about in terms of operationalizing these models. So before I hand it back over to Linda to introduce our other speakers, I just want to summarize, that AI is critical. I think it's becoming very important to organizations, even in the narrow definition that we're using. And it's not just about building the model. Think about these four pillars that start with identifying and articulating, what you're going to be building. And then, also thinking about these data considerations, that you may not have thought about. You may have thought about them at the front of the model, but there's things to be thinking about at the back of the model too. And I think our speakers will be going more into, some of the data considerations around machine learning and what Pitney Bowes and Pegasystems has to offer in that regard. So I'm going to hand it back over to Linda to introduce our next set of speakers. So Linda, back over to you.
Yeah, thank you, Fern. Before I bring our next two speakers into the conversation, I just want to remind the audience that we welcome your questions. If you have a question for any of our experts today, this is a great time to get it answered. So type it in there on your console. We'll answer audience questions toward the end of the hour. On that note, joining Fern today, as she said, we have two speakers, both from PKSI, which is Pegasus Knowledge Solutions, Inc. Larry Hall is an account director for advanced analytics at PKSI. In that capacity, he serves as a senior consultant and artificial intelligence and machine learning evangelist at PKSI. Larry has spent a career in the technology industry as a user, developer, and promoter of advanced technology solutions to help companies address their key business challenges. Joining Larry today, please welcome Dr. Chandra Baji. He's a data science architect, also at PKSI. Chandra has nearly 25 years of experience in the IT industry and over a dozen years of experience in designing and building data warehouses and data lakes and working with BI, data architectures, big data, data analytics, MDM, and related systems for many industries across North America and Europe. With deep roots in data analytics, he's designed, developed, and managed multiple data analytics products and offerings for the insurance, retail, and financial industries. and has successfully delivered multiple large end-to-end projects using a variety of commercial and open source products. Dr. Baji has a Master of Philosophy in Computer Science, an MS in Information Technology, and a PhD in EDW, Data Analytics, BPM in the banking domain. He's also completed the Marketing Analytics program from Cornell University. So welcome to both of our speakers. It's great to have you both on the program. And Larry, I'm going to turn things over to you here.
Yeah, thank you, Linda. And thank you, Fern. We're really happy to be with everyone today and to share some of our thoughts regarding what it takes to be successful in your AI initiatives. Fern's analysis of the market and the business opportunity for artificial intelligence serves as, I think, a great launching point for the rest of our presentation. From here, we're going to pick up where Fern left off and bring into the conversation some real-world considerations, or lessons learned, if you will, that every company should consider as they embark on or maybe take the next step in their AI journey. Before we do this, however, let me give you just a brief introduction into who PKSI is and the relationship that we built with the webinar sponsor, Pitney Bowes. Pegasus Knowledge Solutions is a firm specializing in artificial intelligence and advanced analytics. We've been helping companies utilize advanced analytics and now AI for over 20 years, and in that time, we've come to understand the absolute criticality of preparing data for use in AI and have developed extensive expertise in the area, which is what we'll be sharing today. In our practice, we not only help clients with strategy around advanced analytics and AI, but we also roll up our sleeves and help our clients execute on that strategy, helping them to deliver real business value from the technology. Our partnership with Pitney Bowes is an example of the partnerships we've built over the years with leading technology providers. No surprise, right? The AI landscape is a fast-changing one, and our clients rely on us to help them navigate and understand the ongoing changes in both technology and approaches to artificial intelligence. And our partnerships with Pitney Bowes and with other technology leaders serve as, we think, an invaluable resource to our clients as they travel along their path to AI. And finally, PKSI is a pioneer in the field of pre-built advanced analytic solutions. For those companies without in-house AI staff and skills, and for those who have the staff but are looking for a faster way to get to value utilizing AI, PKSI offers pre-built advanced analytics solutions for both advanced workforce analytics and advanced banking analytics. And these solutions offer pre-built models, data integration, and incorporate AI expertise that is really recognized as industry-leading by analysts such as CIO Outlook. The pre-built solutions that we offer mean clients can start delivering value from AI faster, lower cost, and at lower risk. And we're really proud to be a partner of the sponsor of today's webinar, Pitney Bowes. Pitney Bowes is a leader in all things data, from providing data through its many commercial data sets to data quality and data management solutions. For over 95 years, PB has grown an extensive business, supporting now over 1 million companies or businesses, and that includes 90% of the Fortune 500. Through data management and enrichment, data solutions like location analytics, customer insights, asset management, and risk and compliance management, PB Solutions are helping our clients uncover really key business insights through better understanding of the relationships between people, places, and things. So, back to AI and lessons learned. I'd mentioned that for this part of the webinar, we're going to take a look at some real-world considerations when starting down the AI path. And for that, we'll be using Fern's strategic pillars of AI format. Specifically, we're going to look at lessons learned in the areas of data management and then the impact of new data sources, multi-platform support, data integration, and governance on AI success. We'll also be examining analytics strategies and methodologies to use in analytics development, considerations in explainability, making models operational, as well as model governance, management, and monitoring. And finally, we'll look at trust and governance in relation to your AI efforts. That is, what to consider when it comes to data quality and security, also privacy, ethics, and compliance. You know, when we began to put together our lessons learned for today's session, we thought that these might be even more meaningful if we presented them in the context of an actual AI use case. So we selected a use case that we think will be relevant to every organization that employs people, which is all of us, workforce analytics. I mentioned before that we at PKSI have developed a pre-built workforce analytics solution. So many of the lessons learned come directly from our own experience during that development effort. The leader of our development team is Dr. Chandra Baggi, who's been introduced. I am pleased to turn the floor over now to Dr. Baggi, who'll take you the rest of the way. Chandra?
Thank you, Larry. Thank you, Larry and Fern, for clearly articulating the analytics strategies. As Larry said, we'll be focusing on workforce analytics, for all the three pillars that we're going to talk about now. Here is an architectural view to implement HR analytics. It's a phased approach comprising of data extraction, database schema, security, model development, and deployment. HR Data Hub will host data from various internal systems, that's human resource information system, application tracking systems, survey, payroll, and external systems, particularly the third-party data. If the organization has a data warehouse or a data lake where the HR data is centralized, it will also be a source for data extraction. That said, once the model is built, the outcome can be shown on a dashboard or can be deployed as a service and can be scheduled as a nightly job, batch, or a stream, or on demand. Moving to the next slide. This is HR analytics pipeline. Pipelines are executable tasks to deploy a model, and this is how HR analytics pipeline will look like. Predominantly the three categories: the data sources, the data engineering, and data sciences. Each of the category has its own factors to be addressed while developing a pipeline. For HR analytics, this is a view of source systems and corresponding subject areas that can be leveraged. We're seeing the learning management systems, the human resources information system, employee tracking system, the application tracking system. Each of these areas, source areas, dozens and dozens and dozens of tables. We have to process these tables. We have to extract these tables, this data inside that, and understand the patterns really to go about creating the right pipelines for artificial intelligence. Besides using HR data, we can also use external data. For example, drive and commute time is a good indicator for predicting employee attrition. This slide talks about various data sets that are available with Pitney Bowes. There are hundreds of data sets that can be leveraged for building various predictive insights. Household income, socioeconomic data, housing. These are all some of the data sets that we have invariably used in our data models, and then we are building up a lot of predictive insights based on that. In the sense is that we are marrying this data with that of the internal data from HRIS and ATS systems and are generating predictive analytics on that. Now let's actually focus on the real data engineering challenges. Day to day, we are actually addressing these challenges while building a lot of predictive use cases or pipelines for our internal, external customers and product development. These are the real-world challenges to implement data pipelines while building an AI production system. Pitney Bowes Spectrum platform provides direct support to make many of these tasks easier. We are using those, data integration, data management, data profiling. There are many modules within the Pitney Bowes that can be leveraged to address this, address validations too. Let's go one by one. Let's start with the compliance. In today's world, dealing with PII and GDPR are of primary concern to organizations. If some PII data is required in the model or a dashboard, use appropriate data masking. If EU employee data is being utilized, GDPR compliance is required. Make sure that the data owners have appropriate consent for planned use of data. Moving to extraction, extracting data from multiple systems like HRIS system or the payroll, like the way we have seen it a while, 2 slides back, there are a lot of source systems, is always a challenge. As I said, there are hundreds of tables that needs to be extracted. The PeopleSoft, or you talk about any of the open source, SuccessFactors, there are hundreds of tables that needs to be extracted. We recommend using third-party data connectors to make the life easier. Otherwise, it's a huge development, ETL effort, writing mappings and things like that. And as I said, one of the examples is SAP SuccessFactors. They have a report writer. Report writer is generally used to extract the data from the source systems. It is a manual process. For a data warehouse to be built or a data hub to be built for a HR, you need the data. So how are we going to extract the data from these ERP large systems? There are RPA, robotic process automation, or robots that are available in the market that we can leverage, which will fasten the whole process of automation. Then we go to the integrity. To ensure the integrity of your staged data or analytics data hub, you may have to use a proper ER model. When I say ER, I'm talking about structured format so that the processing becomes easy, extraction becomes easy, performance can also be managed. Now you have enormous tools in the database systems that can store data even if it's going in terabyte. Consistency, this is one of the big challenge, to overcome the duplicate master records. Employee address, employee, all these things are master records. These master records are actually spread across the siloed systems. ATS maintains, applications. HRIS maintains the employee data. Performance maintains the employee data. You have employee data being scattered. You have to finally have a single view of this particular data. That's the challenge. Identifying a golden record from multiple sources is made easier by using some of the tools. Pitney Bowes has master management tool that can be leveraged. This is actually the most wanted thing in case of building predictive analytics, because finally when you subject to the AI, you have to give a single view of your customer or of your employee. In addition, you may also have alert. We have to alert the source data steward about the inconsistency, and this will help in future extraction and operationalization. Because unless you rectify this problem, you will not be solving this forever. Timeliness is one of the key challenges in data engineering pipeline. How often the data is extracted will depend on the rate at which the data changes. Once the frequency of the incremental data is identified, we can automate the data extraction process. These are the real, challenge. Instead of ad hoc queries, data quality side, you can use repeatable ETL and ELT workflows to address data quality problems. That's also a critical aspect. Rather than rewriting large queries using database tree, packages and everything, I would rather recommend to have ETL workflows being built, which are much faster. Maintainability is much faster. These are the some of the real data engineering challenges. Now let's move to the data sciences challenges. Based on our experience, we often see these data sciences challenges in implementing AI. Let's discuss one by one. Some of the critical challenges around here are model bias bias introduced by human, model interpretability or explainability, and model operationalization. Let's talk about human unconscious bias. Bias is a systematic favoritism of a group. Bias does not come from AI algorithms, it comes from the data. In the real-time production, handling unconscious bias is a challenge. For example, if a company had a gender bias unconsciously in the past, model will also reflect this bias. To capture and treat this unconscious bias, try to perform an insightful EDA to the variables. You can also leverage few sampling techniques like undersampling, oversampling, and SMART, which are the techniques that we often use in our lab. Now comes the model interpretability or explainability. In the real world, in the modeling world, both mean the same. In our production, we generally use three types of models. One is the black box, which is also known as opaque. There is the white box, which is also called as a transparent, and there is a surrogate, which is also known as interpretable. Depending on the use cases and the KPIs of interest, one of the above model can be productionized. Explainability merely means ability to explain the model in human terms. That is, your algorithms predict will come up with the scores or some numbers, but then unless you practically explain in terms of English, in terms of sentences, where it will not be really able to be able to convince the people or the management. For example, in an employee attrition use case, the black box model predicts 1 or 0 as a final result with high accuracy. In case of white box model, it predicts 1 or a 0 and also the attributes that influence the result. However, the accuracy is compromised in case of white box. So now comes the surrogate model. We try to convert the black box model to white box in order to balance between high accuracy and explainability. This way, the business user will know the reason behind each prediction he's trying to leverage. So that's about the explainability. So now the slide is for the data scientists. I've covered that. It's actually the flow, the way we have actually implemented. Data scientists can implement the surrogate model. Now comes the model operationalization. So this is a busy slide, but covers end-to-end implementation of the whole flow. It starts with the data extraction, developing multiple models, and finalizing the champion. When I say champion, it's the final model for deployment. PKSI proposes continuous delivery. This is to avoid common AI pitfalls like model degradation due to various reasons. Let's start with one-time snapshot of data that mimics the real world in a continuous operation. Use this extract to build a predictive model. The next automate the data structure or data extract at predefined frequency and a new score data using the predictive model, but on the one-time data snapshot. Evaluate the model accuracy as and when the event occurs. For example, how many actual churns have been correctly identified. This is called the true positive rate in data science language. If accuracy is not satisfactory, return the model or retune the model and store in the data repository. And this is an iterative process which involves model retraining as and when the degradation is identified. The process can be more efficient by implementing techniques like AutoML, which is actually coming up in a big way. So finally, the model ethics governance. The reason why we discussed about bias, the explainability and model operation is to be compliant with the various legal restrictions that exist in the data science space. I may try a few examples here. A GDPR Article 2.2 can be addressed by the challenges discussed in the data engineering slides that I just narrated a few minutes back. The Genetic Information Non-Discrimination Act can be addressed by the methods discussed in unconscious bias methods, we went through. Equal Credit Opportunity Act can be addressed by implementing the methods discussed in the explainability. So this is, these are the widely known or day-to-day compliance that we have to meet, and this is mandatory as we progress with building the data AI modules. So with this, we tried to showcase various techniques and methods to implement data sciences framework in your organization. Hope this was helpful, and I would like to thank you everyone for giving the opportunity, and I'll hand over back to Linda from here.
All right, thank you, Chandra. Let's go ahead and move into our question and answer period now. I want to remind the audience once again that great opportunity to get your questions answered. Go ahead and type them in there on your console and send them over, and we'll get to as many of those as we can. I want to start with, this is a great question for kicking off the Q&A period. And Larry, I'm going to go to you with this one. Someone is asking, how do I get started with the first AI project? How do I get that off the ground? Can you talk about that a little bit? Larry, do we have you there? You're not on mute?
You do now have me here. I apologize, Linda. Yeah, so I'll start, and maybe someone else wants to jump in as well. So, people come to us, generally speaking, one or two ways, right? So they will either have a specific business problem they're looking to solve. How do I reduce customer churn? How do I reduce employee churn, for that matter? In some cases, they'll come to us and they'll go into a webinar or a conference and say, I'm really interested in this artificial intelligence thing. How can it help me? So it's not a business problem at that point. They want to talk more about the technology. But quickly, we bring it back to a business conversation, right? It's just technology until you apply it to a business problem, which is where you deliver the value. So I would say that's kind of where you start, right? Evaluating the business in terms of what the problems are that you're looking to address, what are the objectives of the organization, are the issues around revenue, are they around cost, are they around customer base, and then to figure out how to apply the technological solution from that point of view. So always start with a business problem. I think that was something that came up earlier in Fern's presentation, and we found that to be the most consistent way to really get traction and start a project off on the right foot.
Yeah, that's great. Thanks, Larry. Anybody else want to weigh out on that one? Thoughts on getting started?
Definitely. This is Fern.
Yeah.
So definitely, yeah, I completely agree with Larry. Start with the business problem. And then what you want to do is also, look for something where you can measure an impact, but then oftentimes it becomes, what we hear a lot is, it becomes a sale. You have to sort of sell the idea sort of also in terms of, getting a pilot started. So, you really have to hone your communication skills, in terms of getting different people in the organization bought into it. So that's just, from another perspective, I would say. I mean, there's lots of steps for getting started, but, that becomes important as well. So like what Larry said, you want to pick a problem, you want to look at what the impact is, and then, get people on board. Obviously, you have to look at your data and, what data can actually, help with this, who's going to build the models, all of that stuff. So things to get started with.
Yeah, long list there, but thank you. Here's a question that zeroes in on model governance and management. And Fern, you had said that's often a concern with organizations. So I'll go first to you with this question, but Chandra, I would welcome your input as well. So the question is, our team is small, and so far we're primarily looking at vendors to deliver AI technology. What are the right kinds of questions to ask about model governance and management? What should folks be asking out there, Fern?
Yeah, well, first of all, I would say that model governance is a word, it's not a phrase that a lot of people, think about. So I'm glad that someone asked that question. But in terms of, the actual deployment and the governance of the model, you need to be thinking about, the first question I would have, would be about whether the vendor actually had a model registry, because it's going to be really important to actually keep track of the models and version the models and keep, information about the models there, for governance and compliance rules and regulations. So I would ask about, how the vendor's actually registering the models. I'd also ask questions about, how they manage the models. Some tools let you check in and check out the model. Some of them have collaboration features that enable you to be able to, collaborate with other people, which can be also important to build trust, but really, those are the first couple features that jump to mind. I'm sure that Chandra has others he would like to add.
Yeah, certainly. Based on the domain, there are certain regulatory compliance that the industry has to meet. For example, if an organization is more to do with retail, they have the regulatory compliance. So that has to be met, and invariably that will cascade down to the data science models that we build. Second thing is that while building the data science models, explainability is more important. So you should be able to explain the results and outcome of the particular prediction that is being done. Because, for example, we talked about the bias. The bias situation is more HR, but there could be bias from other attributes that would actually impact the organizational compliance specific to certain acts. So that has to be addressed. And then while tuning and updating the data sciences model, the tuning has to be, has to be considered a lot while updating. That's where the model has to be tuned, and refactoring the models that could also be helpful as far as the compliance regulatory is concerned.
That's great. Thank you, both of you. Let's look at another question on automation. So, Chandra, I think I'll go to you with this one, and I'll put up a slide that probably relates to it as well. So the question here is, how do you automate the data extraction for the data needed for model scoring? Can you talk to that?
So See, data engineering is the first one that will go before this slide, wherein we extract the data from the source system. The best way of addressing any of the data sciences problem is to identify the use cases. Based on the use cases, like you would know what subject areas or what areas that you have to extract. That extraction happens part of the data engineering process. Once the extraction is done part of the data engineering process, then it is subject to data sciences. That's where you have the EDA process, exploratory data analysis, data preparation, data profiling also happen part of the EDA exercise within the data sciences, which is part of the life cycle. And that way it can be handled too. So it will be done in two ways. One is at the ETL level, that's the data engineering level, and once inside the data sciences part of the EDA also, this can be addressed as part of the automation is concerned.
How about this one, Chandra? Does PKSI work with open source models to put them into production?
Yeah, predominantly most of our products are built on Python, Spark ML machine language. Those are the things, and we also have we also work with open source, branded tools too.
Let's see. How about this one? Go ahead. Somebody else? Regarding your garbage in, garbage out comment early on, Fern, in your presentation, someone says, realizing that if we wait for data to be cleaned up enough to be perfect, we'll never get started. At what point is data good enough versus when an organization should be concerned about data quality?
Let me address this. Actually,
okay, Chandra, go ahead.
Sorry. So one of the key things is every organization probably should have the data governance in place. When there is a good data governance in place, the data is under our control. Hypothetically, in a situation where the data governance not in place, then those rules have to be addressed part of our data engineering part and the data that is the extraction process and things like that. Now coming back to the answer, yes, you have to clean the data. That is part of the ETL process. And and then of course part of the data, as I said earlier, and I'm repeating again, during the data preparation phase of the data sciences, also you will address this situation when the model is I think that's the answer.
Thank you, Fern. Any other thoughts on that, or?
No, I agree with what Chandra said. It just was interesting to me, when big data first sort of made, a splash, people would say that, it doesn't matter, the data quality doesn't matter because there's so much data, that, the model will figure it out. Well, guess what? It doesn't work that way. So, yeah, I'm not saying that every piece of data needs to be perfect, but I think it's really important before. Obviously, you need to profile your data, see what's there, and then get comfortable with it before you even build the model, and make sure that, it sort of makes sense to you, not the bias, you don't want to put bias in there, but, you need to deal with, the obvious sorts of things that you need to deal with in any analysis. And then, in terms, you're going to be engineering features also that are going to go into these machine learning models, and you're going to have to make sure that those make sense too, and that there's not collinearity and, all sorts of things that can happen with statistical and machine learning models. So, it's sort of also understanding the techniques that you're going to use and know how the data can affect, what they could do with certain data types, and then, how to understand the output and how not to overfit and those sorts of things. So it's not just about the data quality, it's also about the model being used in conjunction with the data.
Right.
If that makes sense.
Yeah, I can add one more point here. If the model can be actually built, we can judge the accuracy of the model, and we can retune the model as the data patterns changes. This is one way of actually model getting retuned continuously, which is an iterative process. So that technique can also be applied to ensure that as the data changes, we ensure that the model is being revisited or retuned, and then finally one day we can claim that this is the best model to go with.
Yeah, and just one other thing on the data quality, because it seems like there's questions coming in there. I guess, the academic papers, there's been a couple of academic papers, that are out there that, are looking at exactly, sort of this data quality question. So if people are interested, I can give them the link to a couple of papers on data quality that, shows some experiments and whatnot that were run and, issues around data quality. So I'm happy to do that after the event. I don't have the link, with me right now, but there are some interesting papers out there. So happy to share those papers.
Oh, that's great. Thank you, Fern. So contact information there on your screen, folks, if you want to shoot Fern an email for those links. Let's go to this question. I'm going to put your slide up, Fern, about the 4 pillars, which you talked about in your presentation. Someone's asking, do you need the 4 pillars in place before an organization can embark on the AI journey?
I would say no. I mean, yeah, you want to have aspects of these 4 pillars in place, but not every, piece of information in the 4 pillars needs to be there. What we see typically is that, organizations evolve and, typically they start off with the business problem, but the data, we see a lot of organizations still building, machine learning, predictive models off of data, structured data that's in their warehouse, right? So, that's one way that you can go. So you need to be thinking about the right business problems. Someone's got to build this model or partner with someone to build the model, and get the buy-in and stuff. But then, you're using, the data that's in your data warehouse. So it's not like you've moved to this platform or you have, a lot of data integration issues and that sort of thing. Yeah, you need to know some of the methodologies, but you're going to typically start off with, typically organizations don't start off with hundreds of models. They start off with, 1 or 2 models, so maybe they don't need, registries and tooling around, building advanced pipelines and governance and, model governance, even though they should be thinking about the fact that the model's going to decay at some point. But, we see that organizations will typically do a lot of this stuff manually initially, and as they scale their operations, then they look to more advanced tooling for that. I don't know, Chandra, if that's what you're seeing also.
Chandra, do we have you there? Your thoughts on that one?
Oh, yeah. One of the, suggestions that I would have is try to do a pilot first and then step into the big way. Do it in a small way. Identify one particular use case, bring the corresponding respective data from the source systems and do a little of small EDA and, feature engineering to that, and then identify the right algorithm and come up with some predictive thing using that. That will be the start point, When you really want to operationalize the whole thing from A to Z, the pipeline like we showed, that would be an exercise that would probably, you can implement later. So then that way you will get the executive buy-in also in your organization.
That's great. Thank you. Let's see if we can squeeze in one more question. Fern, I don't know if this one goes to you. Someone's asking, if we use A-developed rules to derive business decisions, what controls can we implement in the model to ensure we've not created a self-fulfilling prophecy? Does that one go to you?
I don't know that I understand the question. Chandra, do you understand the question?
Can you repeat the question again, please?
Yeah, what controls can you implement in a model to ensure that you haven't created a self-fulfilling prophecy?
If you're using rules?
If you're using rules to drive business decisions.
Looking for data bias is this would be the one I could answer that.
Maybe we'll try to answer. Yeah, maybe we'll look at that one and send the answer. It seems like it has multiple parts to it, so
I apologize.
We'll send the answer. That's fine.
Okay, I will send that to you afterward, and you can follow up. On that note, we're actually at the top of the hour anyway, so let me close by thanking our speakers today. That was Fern Helper with TDWI, and joining Fern today, both from PKSI, we had Dr. Chandra Baji and Larry Hall. So thank you to our speakers. Also, thank you again to Pitney Bowes for sponsoring today's webinar. I want to remind everyone that we did record it, and we'll be emailing a link to each of our attendees. So that will be your access to the archived version of the presentation. Please feel free to pass that link along to colleagues as well. And finally, on that note, I want to remind you that TDWI offers a wealth of information, including the latest research, reports, webinars, and information on business intelligence, data warehousing, and a host of related topics. I encourage you to tap into all of that expertise. It's at tdwi.org. And on that note, from all of us here today, thank you very much for attending. This concludes today's event.